Every second bloke on Instagram thinks slapping an LS motor into a Hilux or a 2JZ into a Skyline is just a matter of bolting in the engine and the job's done. I'm AJ, a TMR approved compliance engineer, and today we need to talk about why engine swaps are one of the most legally and mechanically misunderstood modifications in the Australian four-wheel drive and performance scene. I'm not here to kill your dream. Swapped cars are some of the best builds in the country, but I am seeing people spend tens of thousands of dollars on builds that are never going to see a registration plate, but I am seeing people drive uncertified swapped vehicles and genuinely not understand the legal hole they are standing in. So let's fix that. In Queensland, and every other state in Australia has equivalent legislation, fitting an engine that was not fitted to your vehicle from the factory is defined as a major modification under the Vehicle Standards and Safety Regulation. That is not a grey area. That is the rule. And what that rule means is that you are legally required to obtain an engineer's certificate before the vehicle can be driven on a public road. Not after you finish the tune. Not when you get around to it, before the first drive out of the driveway. Now, a lot of people hear engineer's certificate and they think it's a rubber stamp. You hand some engineer $150 and they tick a box. That is not what it is. A certifying engineer has to physically inspect your vehicle and satisfy themselves that it meets the relevant engineering standards across multiple systems. If they certify it and it fails, if someone gets hurt, it comes back on them professionally. So a competent engineer takes this seriously, and you need to understand what they are actually looking at. When an engineer certifies an engine swap, they are not just confirming the engine physically fits in the engine bay. They are working through a list of engineering systems that all have to be verified as adequate for the new power output and the new mass distribution of the vehicle. Braking is the first thing most builds fail on. Your factory brakes were designed to stop a vehicle making the factory power figure. If you have doubled the engine output, the engineer needs to be satisfied that your braking system can safely bring the vehicle to a stop under emergency conditions with the new power on board. On a heavy four-wheel drive going from a stock diesel to an LSV8, this often means upgraded front calipers, larger rotors, and sometimes a brake booster upgrade to maintain pedal feel and stopping distances within the legal standard. Cooling system is next. Every engine has a thermal output, the amount of heat it puts into the cooling system. A diesel four-wheel drive is designed around a specific radiator core area, a specific coolant flow rate, and a specific fan capacity. Drop in a V8 petrol with a significantly higher thermal output and run it in Queensland summer traffic, and you will find out very quickly whether the cooling system was reassessed or not. The engineer has to confirm the cooling capacity is adequate. If it is not, you are building a vehicle that will overheat in normal use. Engine mounts and chassis loads are another area. The original chassis was engineered to handle the torque reaction of the original engine. A high torque swap, particularly a diesel swap with high low-end torque, can put different rotational loads through the chassis rails and cross members. The engineer needs to confirm the mount design and chassis attachment points are adequate for the new torque figures. On some older chassis builds, this requires gusseting or additional reinforcement. ECU integration and emissions compliance also get assessed. Can the new engine's ECU communicate with the body control module? Are the airbag and ABS systems still functional? Does the vehicle meet the emissions standard applicable to its compliance year? Here is the practical reality of what goes wrong, and why treating certification as the last step instead of the first conversation is an expensive mistake. People spend $15,000, $20,000, $30,000 on the engine, the gearbox, the custom crossmember, the fuel system, the exhaust, and the tune. The car drives brilliantly. They take it to get certified, and then the engineer tells them the brakes are not adequate, or the cooling system needs to be upgraded before they will sign it off, or the chassis mounts need additional gusseting, and now there is $5,000, $8,000, $10,000 worth of additional work required before the car can be registered. Work that would have been far cheaper to do as part of the original build if they had known about it up front. The single most expensive thing you can do in an engine swap build is surprise yourself with the compliance requirements. Before you touch a single bolt, sit down with a certified engineer and have a detailed pre-approval conversation. Tell them exactly what engine you're putting in, what power level you are targeting, and what the vehicle is going to be used for. Get that conversation on paper. Know what braking upgrades are going to be required as a condition of certification. Know what cooling system changes are mandatory. Know whether the chassis will need reinforcement. Build the car to the spec the engineer tells you it needs to be. This is also where the Facebook group and YouTube tutorial problem bites hardest. Someone has done the same swap in a different state, under a different state's modification standards on a different chassis, and their build video has 3 million views. They did not get an engineer to sign it off, or they got a compliant one in a state with slightly different rules. Their build documentation is not your certification pathway. What passed there does not mean it passes here. The correct reference for your build is your certifying engineer, not the internet. Let's talk about insurance, because the legal and financial exposure here is significantly larger than most people realise. If you drive an engine-swapped vehicle on a public road without an engineer's certificate, your comprehensive insurance policy is void. Not might be reviewed pending investigation. Void from the moment the modification was made without disclosure. The moment your insurer becomes aware of an uncertified major modification on a vehicle you are claiming against, and they will check, because that is their job, they will decline the claim. And here is where people get a very unpleasant surprise. It is not just your own damage claim that gets declined. Your third-party property damage coverage is also affected. If you rear-end someone's vehicle, damage their property, or cause an accident, and the other party's insurer investigates and finds your vehicle had an undisclosed, uncertified major modification, your third-party liability can become a personal debt. In a serious accident, that means medical costs, rehabilitation, income replacement, and legal fees coming out of your pocket directly. People have lost houses over this. The bitter irony, and I want to make sure this lands, is that a certified engine swap is not difficult to insure. There are specialist motor vehicle insurers in Australia who actively want to cover modified vehicles. Shannon's, Club 4x4, and others have products specifically built around engineer-certified, modified, and classic vehicles. The certificate is the thing that makes them comfortable underwriting the risk. Without it, you are completely uninsurable. With it, you are a documented, assessed risk that they can price and cover. One more thing on insurance. Declaring the modification at the time of policy inception is a legal obligation in Australia. If you take out a policy, declare a stock vehicle, and then modify it without telling your insurer, you have potentially voided the policy at its foundation, not just on the modification. Read your PDS carefully and disclose everything. Let's go through the swaps that come up most often in the Australian scene and what each one actually involves from a compliance and engineering standpoint. The LS is the one everyone talks about first. It is torquey, relatively cheap to build power with, and parts and knowledge are everywhere. For a rear-wheel drive classic or a street machine build, an LS is a strong choice. Straightforward certification pathway, well understood mounting solutions, and the modification industry has produced compliant crossmembers and hardware for a huge range of applications. For a heavy touring four-wheel drive, there are additional considerations. You are adding weight over the front axle, which changes weight distribution, front tyre loading, and steering geometry loads. That is not a reason not to do it. It is a reason to have an engineer assess the front end loads and make sure the wheel bearings, steering geometry, and front suspension rates are appropriate for the new weight. The Barra, Ford's inline 6, is an excellent swap for Falcons and rear-wheel drive platforms because it is a factory Australian engine with a well-supported compliance pathway. The challenge is cooling. The Barra runs hot under hard use, and if you are putting it in a vehicle that was not designed around its cooling package, the radiator sizing needs serious attention. The 2JZ is a rite of passage in the drift and performance scene. It is a robust platform that makes good power on factory internals. The compliance challenges are typical for any imported engine swap, ensuring emissions compliance relative to the vehicle's compliance year and demonstrating that ECU integration is safe and functional. The RB26 is another strong platform with a similar compliance pathway. Both are well understood by engineers who work in the modification space regularly. Whatever platform you are building, the swap itself is the part most people have figured out. The compliance pathway is where the knowledge gap is. And that is what costs builds time and money. Here is a straightforward process that will save you money and keep your build on the right side of the law. Step 1. Decide on your engine platform and your power target before you spend $1 on parts. Step 2. Contact a certified automotive engineer, not a modification shop, and have a pre-approval conversation. Tell them the donor vehicle, the engine, the power target, and what you are building it for. Ask them directly what supporting modifications will be required for certification, and get that in writing. Step 3. Source your parts to the engineering spec, not to the forum build spec. Step 4. Build it. Photograph everything. Document your materials, your modifications to the chassis, and your installation method. Step 5. Go back to your engineer for the inspection and certification. If you have followed steps 1 through 4, this should be a confirmation, not a surprise. That is it. 5 steps. The build still gets done. It costs some time up front to get the engineering conversation right, but you end up with a registered, insured vehicle you can drive on a public road, not a trailer queen you cannot legally take to a cruise night. If you want to start that engineering conversation before you commit to a platform, go to totalengineeringmods.com.au and ask Willie to look at your setup. It is free, and it is the first step worth taking. What are you swapping? Let me know in the comments. I genuinely want to see what you are building. Take it easy out there.